So this week we have 3 spotlight students. Actually, we have 6 students who did all the questions correctly. 3 of them were at 3rd grade or under. So those are the spotlight students. So they are Shiyun from Bothell, Washington, 3rd grader, and Hannah Liu from Providence Spring, and Angela Hong from Elizabeth Lane. Okay, so these are spotlight students. I'd like them to each pick a problem to talk about. All right, so I will start with the 1st grader. Okay, Angela, which problem would you like to talk about today?
The first problem.
Okay, the 4th one. Good. Is Hannah here? I think Hannah is here. Which problem would you like to talk about today? Hannah, you can.
The 3rd problem.
Who?
The 3rd problem.
Okay, hold on. Somehow it says my Wi-Fi is not connected. Okay, let me try again. Okay, so Hannah will go with the 3rd one, all right? And Shiyun, which one would you like to talk about?
I'll talk about the 1st one.
The 1st one, okay. So now I have the 2nd one left. I think there is another student who had another elementary school student who had everything correct. Let me see if a student is here. That student is Princeton Xu. Is Princeton here? Okay, if not, how about Kenny? Kenny Chen, is Kenny here? All right, then the 2nd problem is open to everybody else. So anyone want to talk about the 2nd problem as well? Who want to talk about the 2nd problem? Many of you had it correct. Kyle, you want to talk about it? Okay. Can I please, Eric? Eric, yeah, sure. Yeah, you can talk about it. All right, let's go ahead. So who had the 1st one? Shiyun had the 1st one, is that correct? You can mute yourself.
I'm doing the 1st one. I think.
Did you? Yeah, you picked the 1st one, right? Go ahead.
So how I did the 1st problem was I didn't just do 2 minus 4 plus 6 then minus 8 like that. First I did so technically I put parentheses around all of the subtraction ones. And so first I did 2 minus 4 and then skip the plus sign and then 6 minus 8.
Yeah, hold on. Sorry, let me change my pen to somehow this is too thick. Okay. All right. So 2 minus 4 plus 6 minus 8 plus 10 minus 12 plus 14 minus 16 plus 18. Okay. What did you do?
So first I put parentheses around all the subtraction problems.
Okay.
So technically I put parentheses around 2 minus 4 and then skip the plus and then did parentheses around 6 minus 8 and did that for all of the other subtraction ones.
Okay.
And then I did 2 minus 4, which is -2, 6 minus 8, which is also 6 minus 8, which was also -2.
Okay.
And then 10 minus 12 is also -2. So it's 14 minus 16.
Okay.
And then I added all the -2's up together, which got me to -8.
Okay.
And then I did the +18, which got me to 10.
All right. Very good. So Shiyin did grouping. So group 2 minus 4, 6 minus 8, 10 minus 12, 14 minus 16. And then after grouping them, we find they're all -2s, and there are 4 of them. And 4 of them together is -8. And then you add 16, that's 10. Okay, very good.
18, not 16.
Yeah, 18, and then you got 10. Very good. Any other thoughts? Any other comment on this problem? Of course, one way is just to do it from the beginning. 2 minus 4 plus 6 minus 8 plus 10 minus 12 plus 14 minus 16 plus 18. We can also do it. 2 minus 4 is -2, and then plus 6 is 4, and then minus 8 is -4, and then 6 minus 6, 8, minus 8 plus 18 is 10, right? So we can also do it this way. Just do it step by step, okay? Or another way is we can pull all the plus together, right? So all the plus together. We can do these first. 2 plus 6 plus 10 plus 14 plus 18. That's what? 40, 50. And then we start minus. -4, -8, -12, -16. So is this 50? 2 plus 6, 8. 32, 40, 50, yeah. And then we -4, 8, 12, 16. So this is together is -40. So 50 minus 40 is 10. Okay. So the problem with this, this problem is really testing you whether you can shuffle things around or group them together. Okay. So last week we talked about a problem. So they're all addition. When they're all addition, you can shift them, add one first, add the other one later, or add the later one first. You can shuffle them whatever you like. But when we have subtraction, it's different. Okay, so let's say if we have 5 minus 1, it's different from 1 minus 5. Okay, when you have subtraction, you cannot just shuffle them. Okay, but if we have 5 minus 1 minus 2 minus 3, and then plus, let's say plus 6. In this case, we can shuffle these subtractions. We can do 5 minus 2 minus 3 minus 1. This is the same. And then plus 6. We can also move the plus. Before, we can do 6 plus 5 minus 2 minus 3 minus 1. We can all do this, right? But we cannot move, let's say 5 minus 2, change it to 2 minus 5 minus 3 minus 1 plus 6. This is not going to work, okay? So this is called a community property. We can do it, you can apply it to addition, but not subtraction, okay? So if we view subtraction as, say, 5 minus 1, we can also look at it as 5 plus -1. Okay, so in this case, we can shift them around. This is also equal to -1 plus 5. Okay, you can try. See, 5 minus 1 is 4. 5 plus -1 is also 4. -1 plus 5 is also 4. Okay, so in the future, whenever you see a subtraction problem, you can consider this as instead of subtract 2, you can make it plus -2. Okay, and then you can apply the community property. Okay. All right. Any question about this problem? If no, we'll talk about the second one. Was it Eric want to do the second one?
Yup. Okay. Can I please share my screen? Can I please?
No, sharing your screen. I will be using my screens, but you can tell me what to write on my screen.
All right, I see. Can you share your screen, please?
Okay.
Thank you. So, assume the number is x.
Okay. Oh, wow. Okay. Assume it's x.
Yes, and then I think it's -2.
-2. Is that
plus
-3?
3?
Let's see.
And then
-2 plus 3 minus 5
plus 7. And then And then you have to subtract x in the end because it says subtract the original number.
Okay.
So then the x's cancel out, and then you're left with -2 plus 3 minus 5 plus 7. So then you can rearrange that around to get -3 minus 2 plus 7 minus 5.
3 minus 2 plus 7 minus 5. Again, consider these negatives as x plus -2 plus 3 plus -5 plus 7. Then you can shuffle these -2 and 3 and -5 and 7, shuffle them around. Okay, so then you have...
and then you get 1 plus 2 is 3.
Okay, you can group them. 1 plus 2 is 3. So the answer is 3. Very good. Okay. All right, for this problem, if you don't know about x, this is complicated, right? So you put x there. When elementary school student at the beginning, first grader, second grader, third grader, they didn't learn x. What do we do? So we said, okay, there's a number. Oh, Angela? Okay, go ahead.
Can x stand for any number?
Okay, yeah, x can stand for any number. So? Yeah, so? Okay. Okay, so you want to try a number there? Okay, so we can put an x, put a number there. So, if the student doesn't know about x, we just make a number. Let's do 10. Okay, then that become 10 minus 2, right? So I think the problem said x pick any number between 1 and 10, right? So we'll just do 10. 10 minus 2 plus 3 minus 5 plus 7, right? And then at the end, we minus 10. Okay, so we can do this step by step. 8 plus 3 minus 5 plus 7 minus 10. And then 11 minus 5 plus 7 minus 10. 6 plus 7 minus 10. 13 minus 10.
Subtract the original number. So if it's like 8 plus 3 minus 7 plus minus 5 plus 7 minus 10, then it has to be minus 8.
No, I'm doing this. This equal to equal.
Oh, I see.
All right. So then at the end, we're getting 3 as well. So no matter what number you put here, you'll be getting the same 3. The reason is here. But again, when you're in lower grade, you didn't learn this, so just plug in a number, right? Okay. Any question about this problem? Okay. If no, let's move on to the third one. Okay, it's about a book. So Angela's favorite book. I think who got this one? Let's see who got this one. Hannah, right? Hannah? You can unmute yourself. Hannah, you there?
Uh-huh.
Okay, go ahead.
So how I did this problem is like you have to get to 100, but you have to count a lot. So anyways, all the 10s have like a 0 in it, and it's asking how many zeros are in the page numbers. So you can just put 10.
So all the 10s, okay? So you can start with what, 10?
10 and then 20. And then 30, and then 40, all the way up to 100.
Okay, to 90, 100, okay?
Yeah, all the way to 100. And then you still have to get to 109.
Okay.
Well, in the 100s, it has a 1 between them. So I did like 101, 102, 103, 104, all the way up to 109.
Okay.
And then you can count the zeros in those, like all of the numbers. And then when you count them, it equals up to 20.
Okay, if you count all these zeros, they equal to 20. Okay, so the answer is 20. So here, what have to be careful about 100. Right? 100 had 2 zeros.
Yeah.
100 had 2 zeros.
It has 2 zeros. So you just have to count 2 zeros in 100 and keep just counting 1 zero. Because 100 has 2 zeros, so that's the only one you have to count with 2.
Okay, very good. Any questions about this problem? So this is counting digits in page numbers. So all you need is just figure out which numbers to count, okay? And this one goes to 109. In the future, when you're in a higher grade, I may ask you to count all the way to, 2000. Okay, so some big numbers. So for now, this program requires you to know addition and subtraction. So you can just do, counting for these. All right, but if you go to say 1,000, 2,000, then you need some multiplication. Okay. All right. So that's the third one. Let's go for the fourth one. I think Angela, you have the fourth one, right?
Mm-hmm.
Okay. So let's talk about the fourth one. Go ahead. So talk about the problem and then tell us how you solve it.
So I know that everybody in the first round said that they don't know if theirs is smallest or largest. Then in the second round they said I have the largest number. So first I knew that 1 and 6 weren't an answer because no one in the first round said that they were smallest or largest.
Okay, so if this is dice, there will be marks, but let's just say 1, 2, 3. It goes for 1, 2, 3, 4, 5, 6. There will be 5 different numbers, right? So in the first round, let's say if someone get 1, let's say if mom got 1, then what would she say in the first round?
She will say that she has smallest.
If she get 1, she will say, okay, I have the smallest one. What if someone, let's say Leo got 6, then what does he say?
Largest.
Oh, so he will have the largest. So if they all say they don't know if they have the largest or smallest, that means none of them are getting 1s and 6, right? Okay, then what?
So I started at 2, but I figured that 2 wasn't correct because if it was 2, then the other 3 might get 1, and no one said that theirs was smallest, and you would have to determine it, and someone could get 3, 4, 5.
So you're talking about Angela's, right? Yours? So if you got 2, you wouldn't be sure you're the largest, right? So someone else may be getting larger ones than yours, right? Okay.
So we moved on to 3, and if it was 3, it might not be largest either because the other ones would either get 2, 4, or 5.
Okay.
So I did 4, and it still wasn't the largest because someone would get 5, and someone could get 3. So I didn't do 4. And then finally I got to 5, and I found out that it was the answer because if it was 5, no one said that theirs was 6 or 1, which smallest or largest, and the largest point could only go up to 5, and the other people might get 4, 3, or 2, and they could be equal to mine too.
Okay, so they could get 2, 3, 4, 5, but they won't be larger than yours, so you will be the largest one, right?
Because if they were equal, then they're just equal.
Yep.
Because 6 is larger than 5, and no one said that theirs is largest.
Very good. Okay, so that's the last one. The answer is 5. Okay, good. Any questions or comment on the last problem? Was Kyle there? You wanted to talk about something?
No.
Okay, good. Yeah, I think that's it. So any questions about any problems we discussed today and any solutions we discussed today? All right, so that's it. So I will see you in a few weeks then.